So we'll have two different examples here in the opener. The first one, these are actually the results from the presidential primary last week in Illinois for the Democrats. And so we want to figure out between Clinton and Sanders exactly how many votes each one got. So we know that just over 2 million people voted, and we know the percentages that each one of them got. So we want to figure out how many votes, how many people out of that 2,015,647 voted for Clinton and how many voted for Sanders. So how am I going to figure out how many people voted for Clinton here? We know that 2 million and some change people voted, and we know of those 2 million, 50.46% voted for Clinton. So how do I figure out how many voted for Clinton? Emily?
You take 50.46% and divide it by 100, and then you multiply it by the total.
Good. So 50.46% means 50.46 out of 100. So if only 100 people voted, we would have had just over 50 people voted for Clinton. So that'd be just over half, right? So we change that to a percent we change it to a decimal by dividing by 100, and then we multiply by the total number of voters, which was the 2,015,647. Nice big number there for you, right? Now, the fact that it's a big number doesn't make this problem any harder. It's just you got to make sure you type it in the calculator correctly. And then the calculator is going to give us what? When we type this into the calculator, we get 1,017,095.4 people voted for Clinton. Now, would it make sense in this type of problem to say that she got that many votes? Something 0.4?
No.
No, why not?
Because there's not 0.4 people.
Yeah, you can't have 0.4 votes, right? So when we're talking about a number of people doing something or a number of people just in general, we're going to round to the nearest whole number. We're going to talk about whole people instead of parts of people, because that's just weird, right? So instead of a 0.4 person, what are we going to do here? We're going to round it, and we're going to round to the nearest whole person, and a whole person would be in the ones place. So we're going to round that 5. We get rid of the 4. And is that 5 going to go up, or is it going to stay the same?
It'll stay the same.
It's going to stay the same. So I'm just going to get rid of the 4 here. It would be okay when you're doing this to just cross off the 4 and be done. And that's it. That's all you need to do. Now, since we have a little bit of work in here, you could box your answer. As long as you make it clear that's your answer, you don't need to box it. But make sure that it's clear. Make your answer nice and big so we can see that it is your answer. All right, so we had 1,017,095 people voted for Clinton. How about for Sanders? Somebody else help me out with that one. All right, so 48.72. So what we're trying to figure out is what is 48.72% of that 2 million voters. So 48.72 divided by 100, because it's 48.72 out of 100. And then times the total number of voters, which was the 2,015,647. And we type that into the calculator and get what? So when we type that into the calculator, we get 982,023.21. And again, we have the same problem. You can't have 0.21 of a person. So instead of leaving that 0.21 on there, we're going to round it. Rounding to the nearest whole person, we're going to get rid of the 2-1, and what's going to happen with that 3? It's going to stay the same, right? That 3 stays the same because the number next to it, the number we're getting rid of, is less than 5. So again, we can just drop that off, and we're done. Now, the percentages are pretty close, right? So Clinton got just over 50%, Sanders got just under 50%. But if we look at the difference here, she's a little over 1 million votes. He's about 18,000 votes short of 1 million. So she actually got about 35,000 more votes. So the percentages look a lot closer than the number of votes. But in the state of Illinois, out of 2 million voters, 35,000 votes is not that much. All right, now, a couple of things I want to talk about here. How many people added the 1,017,095 to the 982,023 like we did yesterday? Who gave that a try to see what happens? So if we add those two numbers together there, Alejandro, what do we end up with?
1,999,118.
All right, so we get 1,999,118. Does that mean that there's a bunch of votes missing?
No.
Sounds like some corruption, right?
Sounds like people abstained.
Okay, so actually, that's a good thought. It's not that people abstained, because these voters here, they're voting for somebody. This is the number of voters that voted for somebody in this election. What's going on here is something we talked about before, and people are actually voting for some other people too in this election. All right, so there were, I think, 3 or 4 other people that got votes, but it wasn't very many of them. So if we look at what's missing here, we're missing about 16,000 votes. So those 16,000 votes that we're missing were cast for other candidates, but out of 2 million voters, 16 million votes isn't very much. It wasn't really significant enough to put in the chart. Okay, and we'll also see that if we add these two percentages together, what do we end up with? If we add 50.46% plus 48.72%, then we end up with what?
100%.
No.
99.82%.
99.18%. So this represents, the votes for Clinton and the votes for Sanders represent a little under 100% of the votes, because we have a few votes that went to other candidates, about 16,000 of them. So the other 82% of the votes were for other candidates. So I just want to show you real quick, and keep those numbers handy, because I want to point something else out. But we'll notice here that in this chart that represents all of them,
Willie Wilson.
we have 4 other candidates that got votes. But if you look at the number of votes they got, there's a little over 2,000 there, almost 2,000 there, 6,000 there, 6,000 there. So there's your 16,000 missing votes. But if you look at the percentages for each one of those, none of them is even 1% or 1 out of 100, 1 out of every 100 votes. So I didn't put those candidates in the chart because they didn't really get a significant number of votes. Now, one other thing I want you to look at real quick. Let's just look at the numbers for Clinton. We got 1,017,095 votes for her. The actual number was 1,017,006 votes. So we're off by 89 votes. What happened with those 89 votes? This is kind of a tricky thing, but the percentages over here, we had 50.46, so we had a percentage that was a little bit more accurate. But even though it was more accurate than this 50.5, the percent is going to have a little bit of a range in the votes. So anything from about 1,016,020 votes to 1,017,000, actually it's going to be even more than that, but anything within a range is going to have the same percent because we're rounding the percentage. So since that percentage is rounded, it's not exactly the number of votes. It's just going to be close. And we were pretty close, right? Out of 1 million votes, being off by 89 votes is not bad. All right, let's move on to the other one. So we had a survey. This is a survey I took a few years ago about students' favorite book between these two. Actually, series, I should say. Between the Hunger Games series and the Divergent series. We want to know, using these results, what are the percentages that students said Hunger Games was their favorite book series and Divergent was their favorite book series. So how am I going to figure that out? Where am I going to start here? We can't write fractions until we know what goes in the denominator of the fraction, and the number that's going to go in the denominator of the fraction is going to be what? Where's it going to come from? The total number of votes, right? So let's figure that out first. The total number of votes we're going to get just by adding these together. I will tell you that unlike the last one we did, there are no votes missing. Nobody cast votes for something that wasn't up here. So the total we're going to get just by adding these two together, which would be what? 267. Okay? Now that I have that, now that I have the total number of votes, how am I going to write the fraction of students that said Hunger Games was their favorite book series? Yeah, we take the fraction of students that said Hunger Games was their favorite, divided by the total number of students that voted, and we get 138 over 267. Now, I'm going to tell you something here. This can actually reduce, but they're kind of big numbers, and we wouldn't expect you to see it. But we can reduce both of these by 3. So you could reduce it by 3. We're not going to make you do that. All right, we'll let you know if you need to reduce the fractions or not. It's okay to leave it like this, though. So we get 138 over 267 there. How about the other one for divergent series? 129 over 267. All right, and then for each of these, if I want to write them as a percent, how do I write this 138 over 267 as a percent? What am I going to type into the calculator? So we're going to have 138 divided by 267. That gives us a decimal, and then we're going to multiply that by 100% to get the percent. Again, don't forget to show your work here. You need to show your work on these to show us how you're getting your answers. We punch that into the calculator. It does say round your answer to the nearest hundredth of a percent. So let's do that as we write our answer here. What does the calculator give us for this? 51.68. Now, you don't need to write the whole thing out. What matters here is what's going on in the hundredths place and the thousandths place that we get rid of. What's going to happen with that 8 that we keep there? It's going to bump up to a 9, right? So I'm going to get rid of everything after the 8, and I'm also going to change that 8 into a 9. So we get 51.69%. Don't forget the percents on your answers. All right, the other one. We're going to do the same thing except with the 129 over 267. So we have 129 divided by 267 times 100%. And that's going to give us 48.3146. Okay, and again, all we really care about what's going on in the hundredths and then beyond. Since the number after the 1 is a 4, what are we going to do? It stays the same, right? Now, be really careful on this one. What some people want to do is say, okay, here's a 6 right here, so that's going to make this a 5. And then since this is a 5 now, it's going to make that go up to a 2. Don't do that. When we round, you only need the next number after the one you get after the one that you're keeping. So the only number we're going to use to round this is that 4, which is going to make that 1 stay the same. So we end up with 48.31%. All right, and then the last thing we need to do is fill in that last box. What are we going to do to fill this in here to calculate this number? Add the percent. So we're going to add the 51.69% plus 48.31% and get 100%. That ends up to be 100% exactly. Don't need to do any rounding or anything there. Is that what we would expect to get there? Yeah, why do we get 100% there when we got 99.18% on the last one? In the other one, since there were other candidates that were not in the chart, they weren't going to add up to 100% because there were other candidates that weren't represented there but did get votes. All right. In this case, all of the votes are in this chart here, so it should add up to 100% or maybe like 99.9 or 100.1 depending on rounding, but it's going to add up to really close to 100%, if not exactly 100%, because we have all the votes represented here.